Welcome to Chapter 10, Predictive Analytics Part 1, Regression Analysis. In predictive analytics, we make models to predict outcomes. We can use machine learning algorithm to build a prediction model. So, predictive analytics often uses machine learning techniques. In this chapter, we focus on machine learning techniques for predictive analytics, in particular, regression. By the end of this chapter, you will be able to explain the concepts of regression and the model's generalizability and overfitting, explain the hold-out method, and explain how to evaluate the performance of a regression model. As an introductory section of this chapter, let me show you the overview of predictive analytics and the typology of machine learning. Predictive analytics is the third maturity level of the business analytics. We use predictive analytics to answer the question, what will happen? That is, the main goal of predictive analytics is to predict outcomes using predictor variables. Diagnostic analytics and predictive analytics are distinct, but they often use the same methods such as multiple regression analysis and logistic regression analysis. So, some may think that the difference is ambiguous. The primary difference is their purposes. While the primary purpose of diagnostic analytics is to infer causal relationships, that of predictive analytics is to make accurate prediction. Let's consider using a case of multiple regression analysis. In diagnostic analytics, we use a multiple regression model to identify the major causes of the dependent variable. That is, we want to identify which independent variables have a large impact with statistical significance. Here, our focus is the statistical significance and effect size. In diagnostic analytics, we should try to build a parsimonious model. That is, we narrow down the independent variables to a few impactful ones. By doing so, we can identify major causes and concentrate our resources to address the causes. On the other hand, in predictive analytics, we try to develop a multiple regression model that can predict the outcome variable accurately as much as possible. So, the objective of model development is to minimize the difference between the predicted values and the observed values, rather than identifying a causal relationship. So, in predictive analytics, we often input many independent variables into a regression model to enhance the accuracy of prediction. Now, let's recap the difference between supervised learning and unsupervised learning. The first difference lies in their purposes. The purpose of supervised learning is to develop a model that predicts the outcome, or the model should make inference of a causal relationship. In predictive analytics, our purpose is to develop a prediction model. To develop such a model, a supervised learning uses labeled dataset. A label is a variable that represents a predefined category or quantitative measures. A label variable is also called a target variable, an outcome variable, or a response variable. As for unsupervised learning, the purpose is to find unknown patterns in data. Unsupervised learning is applied to a problem where we have no predefined outcomes. That is, even though we have an abstract definition of the outcome, we do not know the specific categories or values that consist of the outcome. Since we have no predefined outcomes, the data does not have a label, so we use unlabeled data for unsupervised learning. Supervised learning can be classified into regression and classification. Regression is used when the label is a numerical variable. So, the purpose of regression is to predict a value of a numerical variable. A regression model is used to find an optimal line to approximate the relationship between predictor variables and the outcome. On the other hand, classification is used when the label is a categorical variable. The purpose of classification is to predict a category that each observation belongs to. So, we use classification to find an optimal boundary line to classify observations into categories. Let's see an example of regression analysis. Suppose we are in the human resource department and analyze employee data. This is data of salespersons. It contains data of each salesperson's age, gender, years of experience, job satisfaction score, and sales performance measured by sales amount. Here, we want to develop a model that predicts sales performance. Sales performance is a numerical variable, so we should use regression in this case. In diagnostic analysis, our purpose is to infer a causal relationship between predictors and the outcome. So, in diagnostic analytics, our focus is to find patterns in existing data. In this case, we build a regression model to identify which predictors significantly affect sales performance in our past or current states. On the other hand, in predictive analytics, our purpose is to make prediction for future outcome. So, in this case, we want to build a model that can predict future sales performance from predictor variables. That is, our prediction model should achieve high prediction performance in future unknown observations. There are many machine learning algorithms that can be used for regression analysis. This is a list of popular algorithms, but it is not comprehensive. But explaining all of these algorithms is beyond the scope of this course. In the following, I use linear regression as an example to simplify the explanation. Thank you for watching. Please thumbs up and subscribe to my channel.